Yep. It's a bit of a different presentation in that I want you guys to think about cybersecurity from the ground, not what's out there, but think about what you guys use at your place, your facilities, your designs. So I'm the Managing Director of TGN, and I'm also the Indersol partner for the England and Wales. So we'll look at why we need it. It's quite evident today why. The difference between OT and IT. Threats and attack paths to our networks, and how we implement some of the fixes to that. So why? How many times today have we heard cloud, cloud app, edge, big data, Industry 4? These are all the reasons why all this data is now going out of our networks. The world of a PLC and a HMI in a cabinet, disconnected from everything, is long gone. Even multiple PLCs up to a SCADA is gone. Everything now has external connections. Air gapping is not an option, really. So OT and IT has merged so that we can use all these features of edge, OPC, cloud networking, big data. And it's opened up our networks to compromise. Our assets have become targets, and we need to protect our data and assets from attack. And the cost of a cyber attack is the financial cost from ransomware, downtime and recovery, data loss, and damage to our reputations. And in the third quarter of 2022, the UK lost £1.6 billion to cyber attacks. We can't afford that. We're in a cost of living crisis. It's a lot of money. So we do a bit of audience participation now. In the news in the past 2 weeks, how many cyber attacks have you heard of? Name some. Well, Chris, we'll pick on you. We've had JD Sports, Royal Mail, the NHS has been hacked. Stuxnet, we haven't spoken about that for a while, but it was the starting point to it all, and we had loads of talk about that. And South Staff's water have been hacked. Bit of confusion over what they were hacking, but it turns out they actually hacked South Staff's water. This was November? I was in South Staff's water mid-December, and it was bedlam. Their OT department were having to build SCADA machines to take out to site. They'd locked everything down. They'd lost clients' data. It was hell. It still is hell. We're trying to do some testing with them, and they won't even let us download onto a test PLC that's offline in case we do something with it. So it's a big thing. We need to address it. So IT versus OT. IT lives in their world. Nice offices full of servers, and OT lives down on the shop floor. And there's a big discussion about IT and OT merging, and nobody wants it, and it's like, oh, they're not doing Windows updates on our SCADA servers, they're not doing this, they're not doing that. It was a big thing. But IT work in a different world to us. So in the blue corner, we have IT. In the red corner, we have OT. And we have different focuses. IT is data flow and storage focus. They want to use the data, they want to move the data, they want to give access to the data to the right people. OT is control focus. We want to use that data, we want to use it to control our plant safely into the right parameters. IT is business functions, it's HR, it's finance, it's your email servers. Arguably, this is the data that the hackers are after. They want people's account details, their passwords, and this is generally where all of the attacking has been, because that data is valuable to hackers. We're looking at manufacturing functions and systems, safety systems. Our data isn't as valuable to hackers, but it's what they can do with that data that's more important. They can hold our plant to ransom, they can stop our controllers, and they can stop us making money until we pay. So that's more personal, that's more in the press. I've had my details stolen. There's already X amount of ambulance chasing lawyers who are putting claims in for your data being stolen for anything. There's not so much about this. This goes unnoticed. Protection of data is critical. Protection of people and process is critical. Totally different reactions to what they need to do. IT can pull a server, they can take something down, they can disconnect a printer. No one's going to really notice. We can't do that in OT. We can't disconnect a PLC. We can't just run up and yank a Cat5 cable out of a SCADA server. It will have an impact on process, it will have an impact on people. So the methods of protection, the methods of reaction are different. IT has a CIA triad, they call it, in that confidentiality, then integrity, then availability. Data must be kept safe, it must be integral. It doesn't have to be available. They can pull the server, they can remove it as long as people can't get at that data. OT, we go for something slightly different and flip it round. We've added control in. We need to control that plant. We need to bring it to a safe stop. We need to finish a process. We need to keep certain things running while we're closing and shutting down. We need the availability of our devices. We lose devices, we lose data. We need the availability of our networks to communicate between all of our devices. Integrity, and then confidentiality. PLC data isn't very interesting. Put that out there. It's ons, it's offs, it's process values. I can't do a lot with that. Well, I can as a controls engineer. As a hacker, great. I've found a tank, it's got a temperature. I can't do a lot with it. I can find people's bank details, that's much more use to me. So our data was really important to us and critical to us, isn't really that confidential. So the good old 5-layer network. Up at the top in the enterprise zone, we've got servers, clients, workstations, data storages, your typical IT in network, email servers. Our world, we have our PLC, devices, SCADA, and then all of our historians and servers. And the bit that we should be doing, and the bit that's important now, is the DMZ, protecting all of our IT and OT from each other is not a bad word for it. We want to stop people here getting down where they don't know what's happening. We need to be sending data up here for people to be using for performance data, metrics, and all of our big data world and cloud data. Edge comes in somewhere around here, so we make sure we've got firewalls protecting that. And most of the protocols, most of the devices that we're looking at now do have encryption, do have safety. Cybersecurity is thought of, but is it implemented properly? The best product in the world will have all of it there, but if it's not implemented and used properly, it's no good. It's giving you an access path still. This is getting a bit old, this layer 5, because what we're seeing now is hyperconvergence, the use of virtualized servers, and this bit is sort of getting squashed into one server, sort of one layer, but with all of these applications and all these virtual machines running in a single device. And that opens up areas where we're trying to segregate virtual machines within the same server. So there's OT, there's IT, and there's the bit that we're all fighting over for no reason, really. So, these are the top 10 threats according to the BSI, which is the German equivalent of the CS, the UK one. In your systems, again, with some audience participation, is where is your biggest risk to your network? What do you think is your biggest risk? Yeah, sorry? People. People are the biggest risk to our network because they're unpredictable. We're stupid sometimes. We really are. We do stupid things and we take shortcuts. Social engineering and phishing. We've had our email from our African prince with our £10 million if we click the link. Most of us aren't going to click that link, but there's always that one person at the factory. We all know who they are, but there's always that one person. The African prince, he's gone away now, It's not as obvious anymore. We're getting a lot more scammy, spammy emails, which are slightly cleverer now in DPD deliveries. I'm not due a DPD delivery, but here's a link for a delivery. As the missus orders something off Amazon she's not told me about again. So they're getting clever, they're getting ways in. Malware from USBs. Doesn't matter how many times we say don't put an unencrypted USB that's not virus checked into a PC, we still do it. And we take that PC that we've got, and we take the code off it, and we go to a SCADA and we put it in. And we know we shouldn't. And we do, because it's easier than trying to send it another method. And it still happens. And it's just a human thing. General human error and sabotage. People being silly. Malware, internet. We've exposed all of our networks now to the internet to get cloud-connected devices. So if we're not securing those routes, we're bringing in stuff via the internet. Internet-connected control components, similar to that one. Intrusion via remote access. Big one for machine builders and those of us in the manufacturing arena. You buy a machine now, they won't give you the code, but they will look after it for you if they can dial in and do all of their changes. It is what it is, whether we agree with that approach or not. Most machines nowadays will come with remote access as standard. Who's installing that remote access? Who's in control of it? Who's got access to it? It's a big thing as we're going forward. Technical malpractice, compromise of extranet and cloud components. You can see all the words from today. Look, cloud, remote access, internet. DOS attacks, or DDoS attacks. And compromise from personal devices in the production environment. So people walking around factories with their phones could be access points if your networks aren't secure and you know what you're doing. DDoS attacks, does everybody know what those are? It's a direct attack, everybody trying to overload your server. Think of it as a malicious version of trying to get Ed Sheeran tickets. Everybody's trying to get onto your network and we'll bring you to crash the server that way. So buying Ed Sheeran tickets is a DOS attack, basically. The server's not big enough to cope with the amount of people going at it. Most days now, a normal person just going at it by themselves can't do a lot. It's got smart on that one. But a distributed denial of service is getting all their mates together and all trying to go for it, and that's got much more success rate. So these are split up. The first two we've decided are our humans. And there's not a lot we can do with them, but we've got security awareness training. It's the first step. It's like the PPE of cybersecurity. It'll make them aware. Password security, malware, USBs, that sort of thing. Not writing the password for the HMI on the front of the panel. And if they can't quite get over, we can lock down ports, so we can do physical restrictions, locking panel doors, taking the keys away, putting in port blockers. I've seen that done. Environment Agency use that approach. You can get them for USB as well. We've actually done that on some water sites, and we've locked all the ports on the server. But this is about physical access, physical restraints, stopping them getting to where they need to do, and the training to go with it so they don't get the dodgy emails, they don't click on the link, they actually think and go, maybe not, I'll flag that and get somebody else to check it out. These are more of our access ones. So these are where we start including firewalls, starting to set up trusted zones, which we heard a few times today. And it's mainly going to be around the IT and the OT separation, where we're accessing the data, where the data is moving to and from. And we try to create the OT network as a trusted zone. So everything that's in there is safe. We know what it is. We've tested it, and it's safe and secure. We can use switches that include routing to create firewalls, internal firewalls, routing of data. And the last one, for the remote access, is using certified remote access products. Well, you can do that through such units. You can do that through VPN access into an engineering station, but by methods which are controlled. So not everybody can access things that are certified to ISO 27001 that have proper access ones. Cool. I actually use that one, it's pretty good. And the last one is about sort of knowing what is on our network. So we're using asset management, we're monitoring our networks. We're pretty good at monitoring networks in OT. We know what's there, we know what should be there. We generally know what isn't there because it's broken. But we know our networks are designed, they're designed from day one. Whether they're kept up to with modifications, but we've got a good idea of what should be there. So when we know what's there, we know what should be there and isn't, or what is there and shouldn't, and that's whether we're using IP addresses to detect what's going on, detecting ports going up and down, or using software to actually monitor the networks and tell us what's happening with them. So this was mentioned earlier in our defense in depth. We don't just look at one or two of these methods, we try to apply as many as we can that's practical, that's not going to make our lives overly difficult to do our jobs, cost us a lot of money. And like with most things with safety, the first one starts with our PPE level, it starts with security awareness of making people aware of what they're doing. Then we create a trusted zone using firewalls, below the DMZ, make sure we've got proper remote access. We look at physical protection, locking ports with port blockers, turning off unused ports in the switch settings, locking the panel doors, putting padlocks on there and just restricting access. And we can look at network monitoring to know what's happening on a day-to-day basis, minute by minute with the network, or to protect our network and our OT network. So it's a multi-level approach, it's scalable. If you haven't got remote access, you don't need remote access security, and you can look at that separately. If you're not really talking up to an MES level, you don't need to look at a firewall and MS and DMZ. If you've just got an OT network with a SCADA and a HMI, but remote access, we need to just scale and look at what we've got. It's fit for purpose. One client, big dairy company, locked down everything. To go and do some work on their site, you must apply for your IP address 2 weeks in advance. You have to have a port unlocked. If you need to install software on their system, you have to give it to them a good month beforehand so it can be installed, tested. And yes, it's secure, but it can make delivering projects and maintenance and diagnostics very difficult on site. Training. We love policies and procedures and standards, but these are the things that will back up what we need. We've all got IT policies that we sign on day one when we're given our laptop. Very little with OT, we don't have a policy for how we're going to connect onto a network and create modifications, how we let people access our network, what the standards are for carrying out work and methods. So supported by policies and procedures also backs up the security training if people can't make the errors if they're following a step-by-step process. And multidiscipline teams, we can invite OT to the meetings. All of this requires on OT as well as IT as well as OT. We are different, we have our different approaches to everything, but at the end of the day, to make it work, everybody has to be working together. It can't be an afterthought. So we can't just turn up with all of our new kit on site and then go to IT. We've got this, we need to connect it. We need to get everybody in on the design. Cybersecurity should be there from day one as part of your network design. Look at defense in depth, look at your policies, your procedures and your standards that you need to support this. Look at your planning, look at what the threats are to your company. Threats will be different depending on the size of your company, the size of your clients that you're working with. Look at a DMZ between IT and OT with the correct firewall rules set up. Look at your initial design. We all do all of this at the start, and then we all know 3 years down the line, somebody will just connect something, or we need to do this modification, and it doesn't get looked at from an impact side of view. What will that do if we suddenly connect this in? We took all this time to create a trusted zone to look at the devices we've connected, and Steve's just gone in and out of the work. We'll just plug that in there, and it's all gone out the window. And look at your selection of components. Look at what your criteria for selection is. Are you looking for products which fit a specific IEC standard? Are you looking for managed switches? Are you looking for certain manufacturers? What is your criteria? And then find your products from there. And just to end with, because we're all engineers and we like seeing atrocities, this was from an automotive supplier. That is as much as I'm going to tell you. They don't supply into Ford, so that's okay. That was a topology scan that I took last summer. There are only 3 managed switches on the entire network down here. That is one network with a subnet of 255.255.0.0. They had split the network because that's on one IP range, that's on another IP range, that's on another IP range. That is the office with the printer, the NAS, the server. These are PLCs, PROFINET, there are PLCs on Profibus and all sorts on there. And there are 3 remote access points for external clients. So it was pretty bad. And actually, we were actually here, where has it gone? We were here on monitoring this network. And the load ratio of the PROFINET network, if you understand what that is, was 25:1. With the amount of TCP traffic and all the traffic whizzing around on that network, the poor PROFINET didn't have a chance. 9 months later, I know that network is still the same. I know they're trying to fix it though, and we're trying to support them with that. But that's possibly the worst I've seen for being one flat network. That 5-layer model that we saw earlier out the window, it's just flat. So there we go. Any questions? Excellent. Thank you very much.